I'm going to find Laplace transform of a periodic function. A periodic function is nothing but a function, the graph of the function is coming in a same interval, the repetition is happened, like sin x. The sin x curve is repeated their image from 0 to 2 pi in the same way. So this that kind of function is coming means you have to use this formula, L of f of t equal to 1 by 1 minus e power minus ps integral over 0 to p e power minus st f of t dt. This is the formula we are going to use to find Laplace transform of a periodic function. So no need to use the basic formula, the basic definition of a Laplace transform. So question, find the Laplace transform of f of t equal to 1 in the interval 0 to b minus 1 in the interval b to 2b. So here this is a periodic function with f of t plus 2b equal to f of t. Sometimes in this question the algebraic form of the expression f of t is given, sometimes in a graphically given like this. So this is the graphical diagram of the given function. Now I am going to apply the formula. So we know that L of f of t equal to 1 by 1 minus e power minus bs integral over 0 to p e power minus st f of t dt. So in this problem p is known as 2b. Try to substitute the correct value for p. B, L of f of t equal to 1 by 1 minus e power minus 2bs integral over 0 to b plus integral over b to 2b. So I have splitted the integral in sum of two integration. Because the function f of t is a piecewise function, it is defined in a two separate interval. So for that I have written sum of two integration. So e power minus st f of t dt, e power minus st f of t dt. Now I am going to substitute. One by 1 minus e power minus 2bs integral over 0 to b. So in this interval 0 to b the function is 1. So you make it e power minus st dt plus integral over b to 2b. In the interval b to 2b the function is minus 1. So minus e power minus st dt. After substituting the function f of t in each interval, try to integrate. If you integrate you may get e power minus st divided by minus s. After integrating you have to substitute the limit plus, here if you integrate this term you may get e power minus st divided by s only. Already one minus is there, so for that I have multiplied that minus. After the integration, substitute the limits correctly. 1 by 1 minus e power minus 2bs. If you substitute upper limits, you may get e power minus bs divided by minus s, minus of minus is going to be plus 1 by s, 1 by s plus, if you substitute upper limit and lower limits in the second interval, you may get e power minus 2bs divided by s. In the lower limit, you may get minus 1 by s. So 1 by 1 minus e power minus 2bs. You can rewrite this term as, I think you may take s as a common term. So from that you may get I think this is going to be minus bs. After taking s as a constant, you may get 1 plus e power minus 2bs minus 2 e power minus bs. So first and third term you have a same term, so I have added. You make it like this. So now I am going to rewrite, I am going to simplify these terms. 1 by s, I am going to rewrite this term as like 1 square minus e power minus bs whole square. The numerator I am going to rewrite this term as 1 square plus e power minus bs whole square minus 2 into 1 into e power minus bs. So this expression is like as a minus b whole square form, is in the form of a minus b whole square. So here you can apply that formula. So here you can rewrite, you can use a square minus b square formula. So from that you may get 1 by s into 1 minus e power minus bs 1 plus e power minus bs. In numerator you may get 1 minus e power minus bs whole square. You can cancel the one term. So finally you may get 1 by s 1 plus e power minus bs into 1 minus e power minus bs. You can take, you can rewrite in every term. If you have a term e power minus x, you can rewrite this term as like e power minus x by 2 plus minus x by 2. Like this you can write. So their addition is going to be a same term, right? So you can rewrite this term as like this. So for that, now I am going to apply this concept in this numerator as well as denominator. So here I am going to take, I am going to rewrite this term as 1 minus e power minus bs divided by 2 into e power minus bs divided by 2. Similarly, in denominator I am going to rewrite 1 plus e power minus bs divided by 2 e power minus bs divided by 2. In a numerator as well as a denominator, I am going to take e power minus bs divided by 2 as a common term. If you take e power minus bs divided by 2 as a common term, you may get e power bs divided by 2 minus e power minus bs divided by 2. In denominator you may get, if you take, after taking e power minus bs divided by 2 as a common term, you may get e power bs divided by 2 plus e power minus bs divided by 2. Suppose if you multiply this term into the closed bracket, you may get the previous term. You can cancel these terms. So which is equal to 1 by s. So this expression is called turn h bs divided by 2. So this is the formula. So finally you may get the Laplace transform of f of t equal to 1 by s turn h bs divided by 2. So here I have used this formula, turn hx equal to e power x minus e power minus x divided by e power x plus e power minus x. By using this formula, I have conclude this step. So second problem, find the Laplace transform of f of t. The function f of t is defined in two separate intervals, and also given that f of t plus 2a equal to f of t. That means the given function is a periodic function of a period 2a. So this graph is nothing but the given function, the graph of the given function f of t. So this is defined like this. So now I am going to apply the Laplace transform of a periodic function formula. By using that formula, I am going to find out Laplace transform. We know that L of f of t equal to 1 by 1 minus e power minus bs integral over 0 to p e power minus st f of t dt. So here in this problem p is 2a, but also the function is defined in a two separate interval. So for that I am going to split 2a by 0 to a and a to 2a. Like this I am going to rewrite this formula. So I am going to rewrite this formula as 1 by 1 minus e power minus 2as integral over 0 to a e power minus st f of t dt plus a to 2a e power minus st f of t dt. Now I am going to substitute the corresponding f of t in a particular interval like 0 to a and a to 2a. I am going to substitute the correct function, which is equal to 1 by 1 minus e power minus 2as integral over 0 to a t into e power minus st dt plus a to 2a 2a minus t e power minus st dt. So here I am going to apply, because the product of two function is coming, so it is not a standard form to integrate. Directly we can't apply the integration formula. So now I am going to apply Bernoulli formula. That means integration by parts. I am going to apply here. So directly I am going to integrate these two integrations. 1 by 1 minus e power minus 2as. If you integrate, you may get t into e power minus st divided by minus s minus 1 into e power minus st divided by s square. If you integrate the first integration, you may get like this. The second integration, you will get 2a minus t into e power minus st divided by minus s minus of minus. So if you differentiate 2a minus t with respect to t, you may get minus 1. In a formula already you have 1 minus, so minus minus plus. So plus e power minus st divided by s square a to 2a. after some simplification I am going to apply the limits. So 1 by 1 minus e power minus 2as, I am going to rewrite this term as minus t by s into e power minus st minus e power minus st divided by s square 0 to a plus t minus 2a. So I have multiplied this minus in the close bracket. So t minus 2a e power minus st divided by s plus e power minus st divided by s square, and the limits, corresponding limits I have written. Now I am going to substitute upper and lower limits. So if you apply t equal to a, you may get minus a by s e power minus sa minus e power minus sa divided by s square minus. So I have substituted the upper limits. You must substitute lower limits also after substituting upper limits. If you substitute lower limits, you may get this term is going to be 0, this term is going to be 0 minus 1 divided by s square plus, if you substitute upper limits, you may get the first term is going to be 0, in second term you may get e power minus s. So I have written like this 2as divided by s square minus lower limit. If you substitute t equal to a, you may get minus a e power minus sa divided by s plus e power minus sa divided by s square. So like this you may get. Now I am going to multiply. If you multiply minus inside the close bracket, you may get this term is going to be plus, this term is going to be plus. If you multiply here, you may get this term is going to be plus, but here this term, the third term, that means the final term is going to be a negative one. So from that you may cancel some terms. I think first and fifth term it's going to be cancelled. So you can cancel these terms. So try to write the remaining terms. I think you may get 4 terms you have remaining non-zero terms. It's not going to be cancelled. So from that I'm going to simplify some. I'm going to apply some formulas to simplify. So from that you may get 1 by 1 minus e power minus 2as 1 by s square minus 2 e power minus as divided by s square plus e power minus 2as divided by s square. So you will take 1 by s square as a common term. So after taking s square as a common term, you may get like this. 1 minus 2 e power minus as plus e power minus 2as. So you can apply the formula. So you can rewrite this term as 1 plus e power minus as 1 plus 1 minus e power. That means you can rewrite this term as like this: 1 square minus e power minus as whole square. Here you can apply the same logic. You can apply a minus b whole square formula. So you can rewrite this term as e power minus as whole square. So if you apply, you may get, you can get the structure for a minus b whole square formula. So I have applied that formula. So which is equal to 1 by s square 1 minus e power minus as 1 plus e power minus as into 1 minus e power minus as whole square. So you can cancel one terms in the numerator as well as the denominator. From the remaining terms, 1 minus e power minus as divided by 1 plus e power minus as. I'm going to take e power minus as by 2 as a common term in the numerator as well as denominator. So from that you may get like this. If you multiply this term to numerator, you may get the original name in a previous step. From that, e power as divided by 2 plus e power minus as divided by 2. You may cancel this term. 1 by s square. Now in the remaining step I am going to apply this formula. Turn hx equal to e power x plus minus e power minus x divided by e power x plus e power minus x. By using this formula you may get turn h as divided by 2. So this is the Laplace transform of the given function.